We're going to talk about quadratic functions, specifically the vertex form, which really just comes from the transformation. So we've worked with that before. We're also going to see how to use completing the square to get from the general or sort of multiplied out form to that vertex form, and how to work with zeros and the factored form. So let's go ahead and get started. We're going to start with the vertex form of the quadratic. I want to just use an example to get us started. So let's say that we've got a quadratic here, and its vertex happens to be at 1, comma 2. If I were to put this together, I would say, using transformations, it would be x minus 1 squared plus 2. This is vertex form. The only thing that we're missing is any kind of a stretch or compression. So if I put it into vertex form, at A. So A is my compression, stretch, or reflection. It could be negative. X minus, we call it h squared plus k. This is our vertex form. So take a look at the similarities here. So the vertex from this example was at 1, comma 2. So we did take the negative there of the number inside. Remember that x shift happens in the opposite direction. And in this vertex form, the same is going to be true. So in that vertex form, my vertex turns out to be, like, I just changed the sign, right? So h, comma, k. Let's work through some examples. In our first example, we have a vertex of 2, comma 3. So h is 2, k is equal to 3, and a stretch by a factor of 4. That gives me my value of a. So a is equal to 4. So as I put this together into my vertex form, actually we can put that right on the answer line. Y is equal to 4. X, I changed the sign on the x coordinate, so minus 2 squared plus 3. Let's take a look at the next one. So for this next one, I have a vertex of negative 1, negative 5. So h is negative 1. K is, oh, actually, yeah, K, that's right, is negative 5. And I don't have the stretch or compression, but I do have a known point. X is 0, Y is 0. So as I put this together to start, I don't know A, but I do know H, so that I'm going to change the sign. So plus 1 squared minus 5. Just like we've done before, I'm going to take my known point, plug those in for X and Y, and then solve for A. So pretty familiar. I'm going to put in 0 for Y, A, 0 for X. Doing the algebra here, 0 is equal to, this is going to be 1 squared. So A times 1, or A, minus 5. I add 5 to both sides, and 5 is equal to A. So this gives me everything I need now. That's going to go right here. Let's go ahead and put this up on the answer line. So we had everything but A here. So as I put it all together, Y is equal to A, which is 5, X plus 1 squared minus 5. A great way to check this is with Desmos. If I go ahead and graph the factored form in Desmos, it should match the vertex and the point that I was given. So let's go ahead and just move over into Desmos. And let's put it in here. So y is equal to 5, parentheses, x, I think it was plus 1 squared minus 5. Okay, so x plus 1, and we want that in the parentheses. So plus 1 squared minus 5. Okay, take a look. So on the graph here, we do have the correct vertex, negative 1, negative 5, and the correct point, 0, 0. So a great way to check is by just graphing those in Desmos or your graphing calculator. Now we want vertex form for the graph represented below. Okay, so we know that our goal is y equals a, x minus h squared plus k. It just has all those transformations in it. If I take a look at my graph, I can see that vertex. My vertex is at 2, comma negative 4. So h is 2. K is negative 4. I don't know the stretch or compression, but I do know a couple of nice points. These are nice points. This is a nice point. This one, because it has 0 in it, I think is the nicest point. So we're also going to use the fact that we've got a point at 0 for x and 4 for y. Let's go ahead and put this information into our vertex form. Y is equal to a. I'm going to go ahead and start with my vertex, x minus 2 squared minus 4. Now let's go ahead and put that point in so we can solve for a. Y is 4, a, x is 0. 0 minus 2 squared minus 4. So just doing the math here, minus 2 squared is 4. So that's going to be 4 minus 4. Add 4 to both sides. We get 8 is equal to 4a. Divide by 4, a is equal to 2. So up in our, where is it? Up in our vertex form that had the vertex in it, I've got a now as well, and that's going to be a 2. I'm going to actually write it off to the side here because I've got a little more room. Y is equal to 2, x minus 2 squared minus 4. Let's put these into, actually just this one, and we're going to match the graph. So let's put that vertex form into Desmos. So y equals 2, whoops, there we go. Y equals 2 parentheses x, and then we've got minus 2 squared minus 4. Minus 2 squared minus 4. Okay, so I should have the same vertex, 2, negative 4, and I do, and that point that I used, 0, 4. So I know I've got the correct vertex form. Whoops. Okay, so back to polynomial functions here. Completing the square. The other way that we can get from some information to vertex form is when we've got, we can call this general form. Everything's multiplied out. Our goal is still vertex form though, because it's so nice to read the transformations and the vertex, x minus h squared plus k. That's our goal. In order to get to this goal, we're going to complete the square, and we complete the square by isolating those x values first. So I'm just going to go through here and start working this. Y is equal to, I'm going to isolate my x terms, x squared plus 2x. I'm going to leave myself some room, and then plus 3. I'm going to end up adding something here, and I need to go off to the side and subtract that same value. To find the number that I want, it's a nice, pretty simple process. I'm going to do half the middle coefficient, so half of 2 is 1, and then before I put it up there on the line, I'm going to square that. So half of 1 squared is 1. But I've changed my function. I increased it by 1, so I've got to go on the outside here and decrease it by 1. If I write what I've got and simplify just a little bit, I've got my perfect square. It's going to factor into something squared. This right here is our perfect square. Plus 3 minus 1, that's going to be plus 2. If we've done this correctly, what I've underlined will factor really nicely. X times x. To get to that 1, I need a 1 times a 1. Okay, perfect. It is something squared, plus 2. If you've done it correctly, you'll always end up with something times itself, which we can write as x plus 1 squared plus 2. So y is equal to quantity x plus 1 squared plus 2. We can check it with Desmos. So in Desmos, let me get rid of this. I'm going to go ahead and write the original polynomial, and I'm also going to type in vertex form for that polynomial. So y equals x squared plus 2x plus 3. Factored form, or I should say vertex form, y equals parentheses x plus 1 squared. Notice how I'm just off by 2, right? Because I haven't typed in that plus 2 yet, plus 2. I can see that these are right on top of each other. If I click on the color, I can see that it places it right on top of one another. So I know that I've got the same graph represented in 2 different ways. So I'm feeling really good about this answer. Okay, so star. Okay, next one, express in vertex form. I'm going to start the same way, and I'm going to isolate my x terms. So isolate those x terms. I'm going to not leave myself extra room for this one to start because I don't have a lead coefficient of 1. Here, I had a lead coefficient of 1, but in this one, I have a lead coefficient of -1. Before I can complete the square, I need that lead coefficient of 1. So I'm going to start by factoring out a -1. So this gives me y equals -1 times, just doing this simplification now, I get x squared. -4 over -1 would be plus 4x. Now I'm ready to complete the square, so plus blank. Let's see, what do we have on the outside? -1, and then I need a blank there as well. So it'd be minus blank. Going ahead and completing the square, I need to do half of 4, which is 2, and then squared. 2 squared is 4. But I've actually changed this, not just by adding a 4, but that 4 is multiplied by a -1. So on this line here, I put the -1 and I put that 4. Okay, where does this leave us? Let me go to a different color so I can get everything in here. So y is equal to, we have our -1 out in front. I've got x squared plus 4x plus 4 inside the parentheses. And over here, this turns into -1 plus 4. So that's going to be plus 3. This guy does factor. I'm going to run out of room. X plus 2, x plus 2, and then the plus 3. Okay, phew. Here comes my answer. Y is equal to -1 or just negative. Remember, this has to factor into something times itself. So we get x plus 2 squared plus 3. Okay, I'm not going to do it this time, but you really should go ahead and graph this one and your original one to make sure that you get the same answer. Okay, part C. So for part C, we're going to tackle factored form this time. And it's just factoring just like you had done in a previous algebra class. So if I want to do it algebraically, so I'm going to do the algebra first. I would do y is equal to, I've got two binomials here, x times x to get to the x squared. To get to the -15, I would do a 5 and a 3. One's got to be negative. I want that -2 in the middle. So I'm going to do -5 plus 3. If I were to look at the zeros of this function, I'd say y is equal to 0. So x minus 5, x plus 3. My zeros then, to make that first one a 0, I would need a 5. To make the second one a 0, I would need a -3. This is how we're going to back into this one graphically. So let's take a look at the graph. Over to Desmos, x squared minus 2x minus 15. So x squared minus 2x minus 15. Take a look at those zeros. I've got one at -3 and one at 5. So I actually could have started this with the zeros. If I know my zeros or my x-intercepts, my zeros are -3 and 5. I can write this in factored form. -3 would have come from a factor of x plus 3. -3 plus 3 is 0. 5 would have come from a factor x minus 5. Order doesn't matter here, but we've got our answer, y equals. So no matter how you do it, you can come up with the right answer. We're really going to be focusing on this graphing method. Let's go ahead and use the graphing method for the next one. 2x squared minus 4x minus 30. Okay, so I'm just going to change this guy. So 2x squared minus 4x minus 30. And I'm going to make sure I've got everything right. 2x minus 4x minus 30, and I do. I just happen to get the same intercepts of -3 and 5. I don't need to go through the algebra to factor this one. So from my graph, oh, let me get a different color pen. So from my graph, my zeros are x equals -3 and x equals 5. If I'm factoring this, is going to be x. For minus 3 to make something 0, I would need a plus 3. I'm changing the signs, right? For 5 to make a factor 0, I would need a minus 5. The only thing I'm missing, which is kind of one of our themes, right, of finding these equations, is the lead coefficient. I'm missing that stretch or compression, so I can go ahead and just drop it in as 2. Without the 2, if I were to multiply the x's together, I'd get the wrong lead term. Excuse me, the wrong lead coefficient. So y is equal to, let's put that on our line here. Y is equal to 2, x plus 3, x minus 5. A really great thing to do here to make sure you've got the right answer is to put this guy into Desmos now. Make sure the 2 match. Number 3. Okay, so for number 3, a quadratic has zeros of -1 and 2. Let's go ahead and label these. So this is x equals -1. I also have 1 at 2, x equals 2, and we're given a y-intercept of 2. So this point is 0, 2. I'm going to use my zeros to put these into factored form. So I've got parentheses, x. For the -1, I would need +1. For the 2, I would need -2, x minus 2. The only thing I don't have, I see there's a reflection. There might also be a stretch or compression. I just don't know. So the only thing I'm missing is my value a, and I'm going to use my point 0, 2 to get there. X is 0, y is 2. So let's go ahead and work the math over here. Y equals. Okay, so y equals, I'm going to put that point in. X equals 0, y equals 2. Put the point in and solve for a. So 2 is equal to, I don't know what a is. X is 0, plus 1, 0, minus 2. So 2 is equal to, just doing the math here, 1 times -2, -2a, divide both sides by -2, and -1 is a. So we only had that reflection. So I'm going to go ahead and put my answer then in green so you can see it kind of separate. Y, in green. Here we go. Okay, so y is equal to negative or -1. Either one is fine. And then my factorization, x plus 1, x minus 2.